Hi, we're here for CCM8, Unit 5, Lesson Number 2, the distributive property. The distributive property states that for every real number a, b, and c, a times the quantity of b plus c is equal to a times b plus a times c. So what we're doing is we're distributing the a to both items inside the parentheses. A numerical example would be as so. If you had 5 times the quantity of 20 plus 6, you do 5 times 20 plus 5 times 6. And of course, you would finish out the problem using order of operations, multiplying first, then adding. Another example was subtraction. 9 times the quantity of 30 take away 2 would be 9 times 30 minus 9 times 2. The reason that we use the distributive property for numbers and instead of, say, numbers and variables would be to use mental math out in the world. So if you have 34 times 102, mentally you would do 34 times 100 plus 34 times 2. 34 times 100 is 3,400. 34 times 2 is 68, and you just put them together. 3,468. Easy. I don't even need a calculator. I could also use this for a subtraction problem. If I had 15 times 29, that's just like saying 15 times 30 minus 15 times 1, because 30 minus 1 is your 29. So if I did all that, I would get an answer of 435. I didn't even need a calculator. We're going to use the distributive property today to simplify some of these scenarios. So example 1, I have 2 times the quantity of 5x plus 3. In real life, in a real scenario, if I could add 5x plus 3, I would. But you see how 5x and 3 are not like terms, so I'm not allowed to combine them. In other scenarios, like I said, we would normally just put them together, but we can't. That's why we use the distributive property, is to continue and simplify our problem if we're stuck and can't combine terms. Distributing helps us simplify. So I drew little arrows here to show, hey, I'm going to multiply 2 times 5x and 2 times 3. So 2 times 5x, that's like saying 2 times 5 is 10. 10x is the answer there. And then 2 times 3 is 6. There's an addition sign here, so there's going to be an addition sign in my answer. 10x plus 6 is the final answer. Over here, 2 times the quantity of 3 minus 7t. So I do 3 times 3, which is 9. 3 times minus 7t is minus 21t. Remember in the first video, you were told that, hey, my answer needs to be in alphabetical order with the constant coming last. So in this case, that's what we're doing. We're just taking our term, minus 21t, because when I circle a term, I circle the operation symbol that comes in front of it, and I move it to the front, and I write plus 9. I'm moving this 9 to the back. The 9 is automatically positive. I know it's automatically positive because it does not have a negative sign. So my final answer is negative 21t plus 9. In this example, I think you can do this example. Try it out on your paper while I do it on the board. Half times 2m, so half of 2 is 1. I can just write it as m, so half of 2m is 1m. I don't need to report my 1 because my 1 is understood there, and I'm trying to write this answer as simple as possible. Plus half times 4 is 2. M plus 2 is my final answer. And then this one here, you'll notice that I'm multiplying at the very end. I'm sorry, my number that I'm multiplying is over here to the right of the parentheses. You can change it. You can change this and move it to the front if you want to, or you can leave it where it was and just draw your arrows backwards, I guess. 7 times 3x, 21x. And then I have a minus there. 7 times negative 2, or minus 2, is minus 14. That's my final answer. A lot of students, when they do distributing, they forget to multiply that number by the second number. So for example, in the first example, some people just do 2 times 5x. They forget to multiply the 2 times the 3. They forget that second term. Do not forget that. That's very, very important. Now we're going to talk about what happens when you have a negative number out front. Remember, a negative times a negative is a positive. So we're going to treat that negative number just like we would any other number we come across. So this problem here is negative 2 times the quantity of 3x plus 5y. So I'm going to distribute negative 2 times 3x is negative 6x because negative 2 times positive 3 is negative 6. Then I have negative 2 times positive 5y. Negative 2 times positive 5 is negative 10. I could write negative 6x plus negative 10y, but I'm trying to write my answer in simplest form. So let as the least amount of numbers and symbols as possible. So what I've got here was exactly the same as what I wrote before, but it's in simplest form. It's using the least amount of numbers, letters, and symbols. Over here, negative 10 times the quantity of 7a minus 2. Negative 10 times 7a is negative 70a. Negative 10 times negative 2 is positive 20. And that's it. Out here, I've got an imaginary 1 sitting here in between the negative sign and the parentheses. So that's like having negative 1 times x, negative 1 times y. I've got negative x, and then negative 1 times y is negative y. So my signs just changed in this problem. And number 4, negative 5 times negative y, negative 5 times negative 8. Why don't you try this one out while I do it on the board? Did you get 5y plus 40? Hope so. Now we're going to do some problems where we have to distribute and combine like terms. So here we go. My first priority is to distribute. 5 times the quantity of 6 plus x, and then I've got plus 3x on the outside of the parentheses. So 5 times 6 is 30, 5 times x is 5x, and I just bring down what I didn't use. I haven't touched this yet, so I just brought it down. Now I'm going to combine the like terms in this problem. 5x plus 3x is 8x. But remember from the previous video, I want my variables to come before my constants. So I just put 8x before my positive 30. My final answer is 8x plus 30. Over here, this is huge. This is an important concept that a lot of students miss. I'm going to distribute first. Most students would just distribute 5, but that's not just a 5. It's a negative 5. Because remember, the operation symbol that comes before that number goes with it. They're together. So I'm actually distributing a negative 5 to what's inside the parentheses. Negative 5 times a is negative 5a. Negative 5 times negative 3 is positive 15. Okay? Once you've gotten all that written down, you just bring down what you didn't use. And now I'm combining my like terms. 2a plus 5a, 2a minus 5a is actually going to be a negative 3a, and then bring down the plus 15. That's your final answer. It's okay to have a negative number out front. That's fine. I'm still following my rules where my terms with my variable come before my constant. All right, here's a big one. Here we go. So I'm going to distribute here and here. 3 times x, 3x. 3 times positive y, positive 3y. Okay, I'm lucky here because I have a positive 7, so that's good. Positive 7 times positive 2x is positive 14x. Positive 7 times positive 3y is positive 21y. From this step, I gotta find my like terms. My like terms are 3x plus 14x. Altogether, that's 17 x's. Then my other like terms are positive 3y and positive 21y. That's positive 24y. Final answer, 17x plus 24y. And here we go, something a little bit more challenging than the last. I'm going to distribute 11 Uh-oh. And then I'm going to distribute negative 6. So here we go. 11 times 2c, 22c. Make sure you're writing this down as I'm writing it on the board. 11 times 7d. Now that's a positive 7d. So I'm left with positive 77d. All right, here we go. Here's the hard part. Negative 6 times c, negative 6c. Negative 6 times d, negative 6d. Don't forget this plus 6 at the very, very end. So I've got 5 terms here. I got to put them together somehow. Let's go with my c's first. 22c, take away 6c. It's going to be 16 c's. 22, take away 6, 16. And then I'm going to take care of my d's. Positive 77d, take away 6d, is still positive 71d. And then what do I do with this last guy over here? There's nothing to put it with, so I just bring it on down to my final answer. Plus 6. And that's it. And as you see, my numbers are in alphabetical order. I've got C, D, and then my constant. So this is it. It's not as horrible as it looks. You just got to take it one step at a time. Let's try some more. So these are sort of like special cases. As you see, we have variables times being multiplied by variables. So again, it's not as complicated as it looks, just take it one step at a time. Y times the quantity of 3 plus z. So y times 3 is just 3y. Not y3, because our coefficient comes in front of the variable. So y times 3 is 3y. Y times z is just yz. Okay? So that's my final answer, 3y plus yz. Here in example 2, I've got m times the quantity of m plus 12. Well, m times m is m squared. M times 12 is 12m. And then I'm done. Okay? Last one. I've got yz squared plus y times the quantity of z squared plus 7. Now remember, our distributing comes first. So y times z squared is just y z squared. Y times 7 is just 7y. And then I bring down this entire thing right here because I didn't use it yet. And then I'll combine my like terms. You see here, yz squared plus yz squared. That's a mouthful. Altogether, I've got 2 yz squareds plus 7y. So one of these plus one of these just means that there's 2 of these. So this is my final answer. Okay, good luck.